Okay, 5.NBT.2, part 2. Now, we ended part 1 with this problem, 75 times 10 to the power of 23, by looking at decimals and finally admitting that there are decimals hiding next to all of these single digits, and even this number 75, there's a decimal point hiding to the right of the ones place, just as we learned in NBT1. Now in NBT2, we also have to explain that patterns in the placement of the decimal point. That's very, very important when multiplying or dividing by a power of 10. So when I look at a number like 75, and I recognize that the ones place has a little hidden decimal there, it's the easiest to really identify and look at and understand if I think, well, maybe if I'm going to take this and multiply it times, I don't know, 10 to the power of 2, that's pretty easy. Well, what if I consider 75 as $75? Then having sense here, well, that makes sense, doesn't it? So if I take this and I look at this pattern of exponents and patterns of zeros that we just learned, what I need me to understand is when money is concerned, those two zeros already exist. So we need to recognize that the placement of the decimal point is affected when multiplying by a power of 10. And in this case, that decimal point, if you haven't guessed already, it's going to move 2 spots, because that's how many zeros we would have created if 75 was being multiplied times 10 to the power of 2. We know that we would have added those 2 zeros. And so there's not much difference when you're dealing with money, except that zeros are already there, and all we're moving is the decimal point. And you can see that happening. And with money, we would put that decimal and those 00 cent placeholders here. So you can see there's not much difference. And in fact, we're not actually adding zeros. We're simply moving the decimal. So when you start to look at examples of this, let's say 12.99. Yeah, it kind of looks like money, but I didn't put the money symbol. If I multiply that times 10 to the power of 3, now, well, what do? We knowingly are going to multiply that times 1, and we're going to get the same numbers, the same digits. But where we thought we were supposed to add 3 zeros, because that's the pattern, we're actually just moving that decimal 3 places. And where we would have put 3 zeros, because that's the pattern of zeros, we now recognize that we only created those zeros, we only created that pattern because the decimal was actually moving. We just never saw the decimal. So now we know that that is actually moving the decimal 3 spots here. And our answer, 12.99 times 10 to the power of 3, is 12,990. Now once you accept that that's what's happening, we can look at dividing by that same power of 10. Except the number isn't going to get really big, it's actually going to get really small, which means that decimal point isn't going to move to the right, because that would make the number very big. Instead, it's going to move to the left 3 spots. And when it moves 3 spots past the 2, past the 1, and past this other imaginary place, that decimal we put there, and we'll have to place a 0. So it's no longer a pattern of zeros, but rather it's a shift in the placement of the decimal point. 0, 1, 2, 9, 9. Now, let's just look at one more example. 3 times 10 to the power of 4, and 3 divided by 10 to the power of 4. While this 3 does have a hidden decimal, we had learned in part 1 that we would just need to add 4 zeros. 1, 2, 3, 4. We're done. That's the answer, 30,000. But here, 3 divided by 10 to the power of 4, that hidden decimal, now, when you're dividing, we're dealing with the decimal because it's going to move the other direction. 1, 2, 3, 4. And we'll have to put 3 zeros as placeholders because of it. And the answer will be 0.0003. Cool? Now don't get too caught up in finding little tricks and patterns, because really just recognizing this placement of the decimal is really what I need you to understand. Because if you have 0.3, 3/10, and you multiply that, it's going to end up moving that decimal 1, 2, 3, 4. And you're going to end up with 3,000. And just as 0.3 divided by 10 to the power of 4 is going to move that decimal the other direction. 0.00003. A very, very tiny number. So, again, you're going to need to explain these patterns in the placement of the decimal point, referring to the hidden decimals that are moving to show the pattern of zeros. And when you're dealing with an actual decimal number, not that it's a pattern of zeros, but that the pattern of zeros is created because of the placement of the decimal point. And that's it for NBT2.